Hello everybody, this is Mr. Strager, and today we are back in Big Ideas, section 5.3. Now, before we jump into the notes, which, trust me, we do have some notes to go over, I want to play a little bit of a game with you. Here's what's going to happen. I'm going to show you two math problems. There are two math expressions, I should say. Your goal would normally be to simplify these expressions. However, I'm only going to put them on screen for about a second each. You need to just decide which one of them is easier to simplify. So, there'll be two expressions I'm going to put up. You need to figure out which one you think is easier to simplify. Are you ready? 3, 2, 1. Here's the first one. 3, 2, 1. Here's the second one. Which of these two is easier to simplify? Let me see if I can zoom out. You can see both the scale of them. You'd probably say, Mr. Strager, please give us the one on the right, not the one on the left. But the more you look at it, the more you might realize these are the same expression. Yeah, these are the exact same expression. The one on the right is easier for a lot of people, though. And why is that? Well, it's because we sort of stacked the like terms. We put all the x's in a stack, and the y's in a stack, the digits in a stack, and the z's in a stack. This is a mathematical principle that many of us are very familiar with. Heck, all the way back as early as elementary school, we've done math in stacks to make it easier. This is much easier to do when it's in a stack. This is one of the key things we'll have to keep track of for today. Now I want to do this again. I'm going to show you two more problems. This time they're both going to be stacked. One of them will be easier to simplify than the other. I want you to try to pick which one is objectively a little easier to simplify. And I'm going to show them both at the same time. You ready? 3, 2, 1, go! So, looking at these, were we able to decide on one that was easier to simplify? Hopefully you caught what was going on with the leftmost pattern. On the left side, if I solve these in a stack, well, 6x minus 6x is 0, 4z minus 4z is 0, 2 minus 2, 0, negative 5 plus 5, 0. These are all zeros. They all cancel out. Meanwhile, in this one, we'll actually end up with an expression. These ideas are going to be really key as we go into the section, because section 5.3 is going to be known as the elimination method. Before we jump into that, there is one vocabulary term on page 144 where we begin our journey. And that term is something we've already talked about in the past. Coefficient. Now, what is the definition of a coefficient? Try to see if you can remember. Do you recall? The coefficient is just another way of saying the number that comes before a variable that's being multiplied to it. The number before a variable that multiplies it. So, for instance, if I gave you the following term, we would know that the coefficient is 5. Similarly, if I gave you this, we would know the coefficient is negative 5. The deal with the elimination method is that we are going to be looking at the coefficients to try to find patterns like this one. Things that we can cancel out. Because the more we can cancel out, or as you'll hear us call it today, eliminate, the easier the problem is going to be. Let's take a look at a problem together. And before we even go through how to solve it, I want us to try and see if we can find a cancellation that takes place. So here we go. Our first equation is 3x plus 2y equals 4. Our second equation is 3x minus 2y equals negative 4. Looking at these two equations, let's pretend for a second that instead of worrying about two separate equations, we just had one mess of variables and numbers. What could we cancel out here? What do you think? Well, some of you might have said 3x and 3x. Why could we cancel those out? Well, because they have the same coefficient. In a different scenario, maybe a problem where it was 3x minus 3x, they would cancel out. Wouldn't it be nice if we did have a subtraction happening here? If we could just subtract these two? If we could only subtract these two, we would only be left with one variable to deal with in both equations, and that'd be pretty easy to solve for, right? Well, this isn't a fantasy. This is the elimination method. The elimination method goes like this. Instead of seeing these as two separate equations, think of them sort of as different parts of a stacked problem, like over here, or like your multiplication problems. Just think of it like numbers in stacks. Well, if we can arrange two equations in stacks like these, we can actually combine them based on whatever stack they are in. Let me give you an example. In order to combine these two equations, combine can mean one of two things. We have to ask ourselves, are we talking about addition or subtraction? Well, if I added each piece together, 3x plus 3x would be 6x. 2y and negative 2y would be 0. 4 and negative 4 would be 0. We could do that. The problem is, right now we're focusing on trying to cancel out the 3x. But those of you who might have been keeping a close eye out might realize that process would cancel out the middle two terms. Right now, we're not trying to overcomplicate things, so we're just trying to figure out how can I combine these in a way that will cancel out or eliminate 3x? Well, if it was 3x minus 3x, then these would cancel out to be 0. They eliminated each other. We would have to continue the problem as normal, though. Keep in mind, just like in those subtraction problems, we're not just subtracting a single part of it, we're subtracting the whole top, or the whole bottom from the whole top. So let's keep subtracting. What's 2y minus negative 2y? Again, we can write this out as this. 2y minus negative 2y, and anytime you have two negatives next to each other, you can convert them into a big positive. So this really becomes, what's 2y plus 2y? Well, it's positive 4y. Lastly, what's 4 minus negative 4? Minus negative is plus, so 4 plus 4 gives us 8. This is the basis of the elimination method. Notice how easy a problem like this down here is to solve compared to these two equations up here. It's easier because we have successfully eliminated, gotten rid of, our x in its entirety. We don't need to worry about x anymore. It just becomes a one-variable problem. That's our goal, to eliminate one variable so we can solve the rest. Let's keep going. To get y by itself, we would divide by 4 on both sides, and 8 divided by 4 is 2. Now, you might know where we're going with this if you watched the 5.2 video. Once you have one of your variables solved for, it's very easy to solve for the the next variable, the second variable. All we need to do is take our answer and plug it back in. You can plug this y equals 2 in to either the bottom equation or the top equation. It doesn't matter where you plug it in, but you should do one that's easier for you. I'm going to plug it into the top one just because this bottom one has some negative numbers. If I can avoid negatives, I like to avoid negatives. So, if we put 2 in where y is, this would become 3x plus 2 times 2 equals 4. Well, now how do we solve this? First things first, we have to simplify. 2 times 2, we know, is just 4. 3x plus 4 equals 4. From here, we would solve this as a two-step equation. There's two things to get rid of. We want to get rid of a 3, we want to get rid of a 4. The 3 is attached by multiplication, the 4 is attached by addition. And according to reverse PEMDAS, we get rid of any addition or subtraction first. So to get rid of plus 4, we minus 4 from both sides. These cancel out, but 4 minus 4 also kind of cancels out to 0. Don't worry, 0 is a number just like the rest, just like how fractions are numbers. 3x equals 0. If we divided both sides by 3, we would end up with x equals 0. This turns out to be our solution. X is 0, y is 2, so our answer is 0, 2. So, yes, the elimination method, the hardest part is just figuring out what to eliminate and whether we should add or subtract to eliminate it. Once you figure that out, everything else is just sort of going downhill in a good way. Like you're riding on a bike going downhill, not like you're tumbling downhill. The key is, you want to look for something to eliminate. In other words, you're looking for the same coefficient. Once you see the same coefficient, you can cancel them out or eliminate them by adding or subtracting. But you know how before I mentioned, hey, we could have gotten rid of these ones too? Keen-eyed viewers might notice, hang on a second, I could cancel these out too. How would I cancel out? How would I combine, I should say, 2y and minus 2y to cancel them out? Well, 2y minus 2y would just be 0. So instead of subtracting here, I could add them to cancel them out. In other words, what I'm saying is 2y plus negative 2y is the same as 2y minus 2y, which is 0. So it can go either way. Even if you have a positive coefficient and a negative coefficient, as long as they're the same number, you can eliminate them. To do eliminations, start off by looking for any similar coefficients, whether they're positive or negative. Then ask yourself, do I need to add these or subtract them to eliminate? Then go through and do that process to the whole problem. The final step is just plugging it back in to find the other number. So let's do a quick practice. I'd like you to flip over to page 145, where we're going to tackle problem number 1. I want you to do the following. You can rank yourself on a 3-point system. You get 1 point for recognizing what to eliminate here, figuring out what in this problem can be eliminated, and how to eliminate it. Would you need to add those two things together? Would you need to subtract them from each other? What operation will give you 0? The second point you would get for finding the first variable, solving for x or y. The third point comes from plugging in that answer and finding the last variable. So try to see if you can tackle all 3 points with this problem, problem number 1. Pause the video. We'll come back in just a moment and discuss how to go through problem number 1. Hopefully you had a chance to try out this problem on your own. If you haven't, seriously, go back and try it out. There's a reason why I pause these videos. I want you to see for yourself how well you do without me talking you through it. Then you can check your process. All right, let's begin the problem. First things first, we need to identify something to eliminate here. Hopefully you caught that the only thing we can really eliminate, at least at this time, are the x's. This is just 1x. This is negative 1x. As a reminder, anytime you don't have a number in front of an x, you can put an imaginary 1 there. So these two will cancel out. Okay, that's fine and dandy. But how will they cancel out? How can we eliminate them from the problem? We have two options, addition and subtraction. What I like to do, if I can't decide, is write down both options and try them out. The only way to know for sure is by trying it out. So let's do x plus negative x right over here. Let's do x minus negative x over here and simplify these expressions. Well, x plus negative x. Anytime you have plus a negative, you can rewrite it as minus. So this turns into x minus x, which is 0. If you did the other side, you would know that minus a negative is the same as plus. X plus x is 2x. So we don't want to subtract here. If we subtracted here, we would not eliminate it. We'd get a bigger number. We want to subtract in order to eliminate. All right. Beyond this, we know we're going to add here, and we're adding the entire bottom to the entire top. So we use parentheses just to say, hey, reminder to future me, this is the operation that we're doing with each piece. So x plus negative x, we already did over here, is 0. That's our elimination. 3y plus 2y is 5y. 17 plus 8 is 25. So to solve this one, we just have to divide by 5 on both sides, giving us y equals 5. So far you got 1 point if you figure out we had to add the x's to eliminate them. You got another point for getting y equals 5. Let's see if we can go for 3. To go for that third point, you would have to plug this back in to an equation of your choice. You could plug it into the top or the bottom and you will still get the same answer. So don't stress out about which one to plug it into. Just plug it into whichever one feels easier. Again, me personally, I don't like messing with all these negatives. So I'm just going to plug it into the top one just so I don't need to deal with them. I think a lot of folks will feel the same. When we solve this, we plug in 5 where we see y. So this becomes x plus 3 times 5 equals 17. Okay, well, let's simplify. 3 times 5 is 15, so this is x plus 15 equals 17. And to finish it off, we want to get x all by itself. There's a plus 15 attached. Let's subtract 15 from both sides, giving us x equals 2. So you got all 3 points if your answer was 2, 5. Very nicely done. This is all fine and dandy, but why are we doing this? Well, if we take a look back at the first problem that we did in this, the very first one that we worked on together, if we just look at the problem itself, we have 3 methods now for solving. We know how to solve by graphing, we know how to solve by substituting, and now we know how to solve by eliminating. If we tried to graph these, because they're in standard form, we might be very tempted to put it, just the x and y intercepts, using the thumb method. I would cover up one, solve for the other. The problem with this is that when you use the thumb method here, you'll get some fractions. 4 over 3, for instance, would be the x-intercept. It gets even worse down here when there's a negative 4 over 3. So the graphing method, while it will still work, might not be the quickest way of doing this. Alternatively, we have the substitution method. And those of you who are well practiced in the substitution method are already looking at this and going, nope, that looks terrible. Bye-bye. To substitute, you need to get a variable by itself, and these variables are extremely close together. So you need to do all those steps. Then you'd have to plug in that long equation back into the other one. The quickest way to do this particular problem would be elimination, because you can just get rid of something right off the bat and solve what's left over. You might be saying then, Mr. Strager, if we could use any of these three methods anytime, what about problems where we don't have an elimination we can do? Let's actually turn the page to page 146. We'll explore this idea in problem number 10. Problem number 10 is x plus 2y equals 20. And the other equation is 2x plus y equals 19. Now, you may notice there is nothing that can be eliminated here. X and 2x have different coefficients. 2y and y have different coefficients. It seems like we've lost all hope. However, stick with it because the elimination method is always there for you. It's always got your back. But it is going to require a little bit of puzzling. See, elimination isn't just like all the other math problems where you would just go through and every math problem is just a procedure. There's still a procedure with it, but with this, we might need to figure out a little bit of a puzzle. How can I make an elimination pop into existence? Let's take a look at the x's, for instance. How could I, Mr. Strager, change one of the equations so that it looks exactly like the other? To solve this conundrum, I will give you a little bit of a hint. In Unit 1, we said there was one major defining rule of algebra, which is you can do whatever you want to an equation as long as you do it to both sides of the equation. Hopefully that gives you enough of a quick start to try this one out. Again, I want you to just figure out what can I do to make an elimination exist. Pause the video, try it out. What are you thinking? Obviously it'll be hard for you to respond through the video, but hopefully we were trying to think about how to get these x's to look the same. Well, if this one, for instance, had a 2 in front, they'd be exactly the same. But I can do anything I want to an equation as long as I do it to both sides of the equation. How could I turn 1x into 2x? Some of you might have said, let's add another x. And while the idea in principle is sound, the idea is good because you'd have 2x over here you would have 20 plus x. That's a whole nother level of complexity I don't want to deal with. I don't want x on different sides. However, you might have also noticed, instead of adding an x, what if we just multiplied the entire top equation by 2? Yeah, this is something we can do because you can do whatever you want to an equation as long as you do it to both sides. If I multiply the entire thing by 2, it's being done to both sides, so we're good. Well, this would give us 2 times x is 2x, 2 times 2y is 4y, 2 times 20 is 40. Then down here, we would still have our old second equation, 2x plus y equals 19. Okay, now they have the same coefficient. So let's ask ourselves, what can we do to eliminate these two x's? Well, it's either going to be addition or subtraction, and if you don't know which, try both of them out. Ask yourself, what's 2x plus 2x? What's 2x minus 2x? And you'll see that we're actually going to have to subtract everything in this problem because 2x minus 2x eliminates out to give 0. From here, let's keep subtracting. 4y minus y, well, that's going to be 3y. 40 minus 19 is 21. This one is pretty easy to solve. All we need to do is get rid of multiplying by 3. So what's the opposite of multiplying by 3? It's dividing by 3. If we divide by 3 and cancel this out, we get y equals 7, which means we're almost done with the problem. All we need to do now is take y equals 7 and plug it back into our equations. Here's a fun little side note. Even though we usually like to just plug it back into one of the original equations, and it's a good practice, you should almost always do it, for this particular type of problem, it's even okay if you plug it into one of the new versions, the ones that you changed, and it'll still work out. It's kind of crazy how that happens. But just to be principled, and just to do things like we've always done them, let's plug this back in to one of these two, our original equations. I'm thinking, let's plug it into the top one. Why not? We could plug it into the bottom one, but I'm going to plug it into the top equation. When I do so, the top equation becomes x plus 2 times our y value is 7 equals 20. Let me move my camera. There we go. And we can simplify this pretty readily. The trick is 2 times 7 is going to give us 14. So x plus 14 equals 20. To get x by itself, we have to get rid of plus 14 by subtracting 14. And we end up with x equals 6. So this is how you solve when you don't see an elimination. You have to make an elimination exist. You can do that by multiplying or dividing an entire equation by some number. There's one more challenge I want to pose to you before we wrap up for today. The challenge I'd like to pose to you is this. This problem was nice because you can multiply x by 2 to get 2x. But what happens if I give you an absolutely wild problem, like problem number 17 in your student journal, which goes 8x minus 3y equals negative 9, and 5x plus 4y equals 12. In this problem, we have to ask ourselves, shoot, what can we do? I mean, I can't multiply 8 by something to get 5, or 5 by something to get 8. I can't multiply 3 by something to get 4, or 4 by something to get 3, at least not without fractions, and we don't want to deal with those. Keep in mind the number one rule. The golden rule of algebra is just, you can do whatever you want to these equations, as long as you do them to both sides. Maybe some of you caught it. Yeah, if we try just multiplying one of our equations by a number, we're never going to get there. It's never going to happen. But who said we can't multiply both equations by different numbers? Let's take a look at the y's, for instance. If I really wanted to eliminate these y's, is there a number I can multiply the top by, and then a different number I can multiply the bottom by, so that they have the same number? Again, we don't care about positives or negatives, so actually, what if we made these both 12? Because, think about it, 3 is a factor of 12, and 4 is a factor of 12. So let's try to turn these both into 12. Well, what do we need to do to turn 3y into 12? Or in this case, technically negative 3y. Well, we can multiply by 4. That'll give us the following. 8x times 4, 32x. Negative 3y times 4 is negative 12y. That's the 12 we were talking about. And 4 times negative 9 is negative 36. Okay, Mr. Strager, okay, I see what you're doing here. Can you figure out how to get this other part to look like 12? If we multiply by 3, that'll give us another 12, and we can eliminate. 3 times 5x is 15x. 3 times 4y is positive 12y, so there's our elimination. And 3 times 12 is positive 36. Let's ask ourselves then, what do we need to do to eliminate negative 12y and positive 12y? Well, I can't subtract them because it would turn into negative 12 minus negative 12, or minus 12. That's negative 24. But I can add them together. A general little tip for you, although I don't want you to rely on this fact, is if the signs are different, like one's negative and one's positive, you can add them to eliminate. If the signs are the same, like they're both positive or both negative, you can subtract. But that's just a fun little tidbit. 32x plus 15x gives us, 47x. Oh, math teacher, I know math. Negative 12 plus 12 is 0. That's our elimination. You don't need to use this symbol, by the way. This is just a 0 with a big line through it. I like to really make a dramatic show of saying, I eliminated this part. And negative 36 plus 36 is 0. So we divide it out. We would divide by 47 in both cases, giving us x equals 0. Wouldn't be the first time we got x equals 0 in a problem. After that, we plug it back in to one of our choice. I'm going to plug it into the bottom one. I don't like this negative 36. I don't like the way it's looking at me. When I plug it into the bottom equation is 15x plus 12y equals 36. So it'll become 15 times 0 plus 12y equals 36. Again, technically, it would be best principles to plug the x into one of the original equations. That was my bad. In fact, you know what? You could do this and you'll still get the same answer. Just to be principled and just to show the proper way of doing it, I'm also going to plug it into one of the top ones. So scratch that last bit. I'm plugging it into the top one up here. I apologize for a little double take. We would have 5 times 0 plus 4y equals 12. 5 times 0 is 0, so we would just have 4y equals 12. And by dividing by 4 on both sides, y equals 3. All right. Very nice, everybody. Thank you so much. If you really want to test your skills, try out problem number 19. Problem number 19, you have to set it up like we have every other word problem. It's just a little bit of extra practice for you. All right. I will see you in the next video, everybody. Have a fantastic rest of your day.